Yes. Hello everyone, welcome to MK Academic Solutions. So in this video I am going to explain you order of reaction. Okay. Now let us see the order of reaction. Okay. What is order of reaction? Order of reaction generally indicated with N. Okay. So order of reaction is the sum of powers of concentration terms. The sum of powers of concentration terms. Powers of concentration terms in rate equation. In rate equation or rate law is called what? Order of reaction. So here order of reaction is always we determine experimentally only. There is no theoretical methods to determine the order of reaction, but we only determine the order of reaction by using experimental method. See here, order of reaction determined by only experimental method. Okay, we cannot determine the order of reaction simply by seeing balanced chemical reaction. Order of reaction cannot be determined by using stoichiometric equation or balanced stoichiometric equation. Okay, see here, order of reaction cannot be determined by using stoichiometric equation. Okay, see here, order of reaction we determine only by using different experimental methods are there. Okay, right. See here, next for elementary reaction. Elementary reaction means the reaction which completes in a single step are known as elementary reactions. For elementary reactions, the order of reaction is equal to sum of stoichiometric coefficients. Sum of stoichiometric coefficients. But here the coefficients. But the thing is here, by seeing the simply the reaction, we cannot tell whether it is a elementary reactions or complex reactions. Compulsory we need to verify the mechanism. After verifying the mechanism only we can come to know whether it is elementary reaction or complex reaction. See, for example, let us assume these are the following are elementary reactions. So let us consider some hypothetical example for elementary reactions. For example, XA plus YB plus ZC is gives rise to product. So what we are assuming, it is we are assuming it as an elementary reaction. Okay. So in elementary reactions we know rate is equal to rate equal to K into A power x, B power y, Z power c. So here order will be, what is order? We know the sum of powers of concentration terms. Okay, here x plus y plus z. So here we are assuming it as an elementary reaction. That's why the same stoichiometric coefficients only we are going to take. Okay. See, next let us take 1a plus 1b. Let us consider this also an elementary reaction and it is giving us a product. Okay, so here what is the order? What is the order here? Simply we use rate law. So here rate is equal to K into A power 1 and B power 1. Rate is equal to K into A power 1, B power 1. Therefore, order is equal to 1 plus 1, that is equal to 2. Okay, 1 plus 1, that is equal to 2, right? So this is for elementary reactions we can write like this. But if you take complex reactions, how we write the order of reactions for the complex reactions? Means compulsory we need to see the reaction mechanism and we need to go through the some experimental methods, then only we can find the order of reaction. Okay. So now let us discuss some important facts about the order of reaction. Some important facts about order of reaction. So what are that important facts? Let us see here. Okay. First, the order of reaction, the order of reaction may be a whole number like 0, 1, 2, 3, 4 and so on, or it may be a fraction, like 1 by 2, 3 by 4, or it may be negative also, Okay, see, for example, H2 plus I2 on metal surface, we are going to take to form 2HI. Sorry, not this reaction. Okay. You take this one. H2 plus Cl2 gives rise to 2HCl in presence of sunlight. So it is a zero order reaction. It is what, children? It is a zero order reaction. And you take the decomposition of ammonia, 2NH3 gives rise to N2 plus 3H2 at very high pressure. These are what? Zero order reactions. So here what is the order of these reactions? Order is equal to 0 order reactions. And you take one more example. Here decomposition of you take one decomposition of ozone, you take, okay, 2O3 gives rise to 3O2. 2O3 gives rise to 3O2. So here rate is equal to K into O3 square O2 power minus 1. So here with respect to oxygen, respect to oxygen, with respect to oxygen it is negative -1, with respect to O3, with respect to ozone it is +2. So the overall order is the overall order is +2 -1, that is equal to first order. Means here order may be negative also possible and order may be fraction also possible. Let us take example CHCl3 plus Cl2 is gives rise to CCl4 plus HCl. So here rate law for this reaction is rate is equal to K into CHCl3 Cl2 power 1/2. So here nothing is there, means 1. So here order with respect to Cl2 is what? 1/2 fraction, and overall order is also overall order is 1 plus 1/2 total, that is 3/2. Means the order may be 0, 1, positive, negative, anything is also possible. Okay, next so sometime, so by seeing these reactions, sometime the rate equation may also contain, even generally rate law contain what? Reactants. We know generally rate law contain what? Reactants, but sometime the rate law also contain products also. Okay, so rate law generally contains reactants, generally contain reactants, and sometime it may also contain products and catalyst also, but it never contain intermediate. So intermediates are not present in the rate law. Why? Because intermediates are produced in the middle of the reaction, again they are going to consume in the middle of the reaction. Okay, so here generally we know reactants are present in the rate law, but what I am telling here, sometimes products also present, sometimes catalyst also present. See for example, so previously decomposition of ozone you take O3, 2O3 is gives rise to 3O2. So here what is the rate law for this? So your rate is equal to K into O3 square and O2 power -1. So here what is the O2? O2 is the product. Here this reaction this rate equation contains what? Product. Means sometimes the rate equation may also contain what? Product. Means the order of reaction also sometimes depend on what? Product also. Okay, next you take SO2 plus O2 in presence of NO, means it is the catalyst here and it produces 2SO2, here it produces 2SO3. So here rate is equal to O2 power 1 and NO power 1, O2 power 1 and NO power 1. Okay, means here what is NO here? NO is the catalyst, means sometimes catalyst also present in the rate equation. Okay, next Okay, these are the some important points. And rate or order of reaction, order of reaction does not depends on stoichiometric coefficients. But order of reaction may depends on the conditions of reaction. Order of reaction may depend on conditions. Conditions like conditions of reaction. For example, here you take the decomposition of gases. Decomposition of gases at high pressure on metal surface is zero order, whereas at low pressure first order. Means like these conditions it is going to be depend. Okay, so this is about the some important facts about the order of reaction. Okay, next we will see zero order reactions. Okay, we will see what zero order reactions, very important for the exam.